Welcome to Train Signal. This is the Understanding Windows 7 Storage Options lesson in the Windows 7 Administration Training course. In this lesson, we'll go over a number of items all related to storing your data on Windows 7 machines. We'll start with a discussion about what's called deconstructing basic disks. We'll break down basic disks so you can get an understanding of this foundational building block of Windows 7 storage. We'll then talk about the differences between master boot record and GUI ID partition table, or MBR versus GPT disks, and what the pros and cons to each of those are. You'll then get a look at Disk Manager's basic disk view of both master boot record and GPT disks, understanding that Disk Manager is the tool by which you will manage all storage in Windows 7. From there, we'll move on to what are called dynamic disks. These are a newer type of disks that enable a lot of powerful functionality in Windows 7. You'll get a look at the different kinds of volume types that are available with dynamic disks, and you'll get a look at a Disk Manager dynamic disk view showing you how dynamic disks operate. We'll then move on to overall management of storage volumes, and we'll end the lesson by talking about the difference between the file allocation table and NT file system, the two options that are available in Windows 7 for storing data on your disks. Now that you've seen what we're going to cover in this lesson, let's move on to the why behind why Windows storage is so important. As is the case in many organizations, data is the lifeblood of GlobalMantic. A lot of companies, when they have a disaster, don't recover from that disaster unless they actually have a way to get their data back. That just underscores the importance of data. Without that data, companies cannot recover, and they really can't operate, and GlobalMantic truly understands this. There's a lot of users at GlobalMantic that have different storage needs than the general user population. For example, database administrators need that additional storage protection. Now, the reason for that is because they're working with systems that they're going to be using live data against, and they want to make sure that the fruits of their labor don't go in vain if they have a storage issue. So, for the general user, if a hard drive fails, it's an inconvenience at best. For the database administrator, it can be catastrophic because they could see weeks and weeks of work lost because the database administrators at GlobalMantic work very locally to begin with. Now, most users, they'll save their stuff to centralized storage in a data center, but that's not the case with the database administrators. They need that local storage in order to do their jobs, and they need to make sure that it's well protected against failure. The GlobalMantic business analysts are the guys that go through reams and gobs of data, and they take a look at their customer database and they mine it for more opportunities. These guys need really speedy storage with a lot of capacity. There's so much data getting thrown at them from their various places that they gather data, including their e-commerce website, their mobile sales force, and more, that these guys are constantly being inundated with more data. Now, if they've got slow storage or they don't have enough storage, it really hinders their ability to do their jobs. So these guys have different storage needs than the regular user population as well. They need it to be fast, and they need it to have a lot of storage. By the end of this lesson, you're going to understand the Windows 7 storage options so you can make the best possible data availability decisions, particularly for non-general users like the database administrators and the business analysts. You'll also understand some storage options that enable higher security levels. Now, we're not going to be discussing things like encrypting the drive and stuff like that in this lesson. We will in a future lesson. But you will get a look at some security features that are built into the underlying storage architecture that can help make sure that your data stays safer. Remember, GlobalMantic is still recovering from a data breach that could have been prevented with better storage options and better security on their storage. So it's important to make sure that when you're developing the GlobalMantic system rollout plan, Windows 7 rollout plan, that you can point out where they can make better decisions with regard to storage to help them recover from this fiasco of a data breach and, more importantly, prevent another one. Now we're getting into the meat. We're going to start by deconstructing basic disks of the master boot record variety. Now, when I say deconstructing, I don't mean we're going to physically tear a disk apart. We're going to logically tear a disk apart so that you can understand the components that make up storage in Windows 7. Now, I've specified master boot record type disk for the initial part of this course because we're going to look at basic disks of the master boot record variety to begin with. These are the most common types of disks in desktop machines, and they've been around forever, since the beginning of Windows NT. There are other kinds of disks that enable other kinds of functionality that we'll go over later in this lesson. The basic building block of a basic disk is called a partition. This is a portion of a physical hard drive that can be formatted and used as an individual storage volume. If you look at the diagram, it's a pretty simplistic diagram. This green thing is a partition. Now, this bigger box is a full hard drive. So what you're seeing here is that a partition is really just a segmentation of a physical hard drive. You're basically saying, I'm going to give this much space to this partition, and I'll give this much space to these other partitions, and then this much space to this partition. And if this doesn't make sense yet, don't worry about it because it will in a few minutes. On a master boot record type disks, there's two kinds of partition. There's a primary partition and an extended partition. A hard drive under the most common type of disk can have only up to 4 primary partitions. So what you're looking at here are 4 partitions. We got a green one, a yellow one, and a purple one. One of these partitions is designated as active, and in this case, that's the green one. The active partition is responsible for booting the operating system. So basically, Windows 7 is installed on the active partition of a master boot record basic disk. Now, I mentioned that a primary partition only allows up to 4 primary partitions on a master boot record basic disk. You can actually have additional volumes. Now, the little hard drive indicator here is a volume in what's called an extended partition. Think of this extended partition, which you're seeing here, as a container. This container can then hold 1 or more volumes. Now, storage volumes on an extended partition cannot be used to start the operating system, but they can be used for operating system storage, like putting data files and things like that. So in this case, any of these 3 partitions as primary partitions could be used to start the operating system as long as you installed Windows 7 to one of these partitions. However, these 2 volumes in this extended partition are persona non grata as far as booting the operating system goes. You are not able to boot the operating system from either of these volumes because they exist in an extended partition. The traditional basic disk with a master boot record type system has some limitations. Now, it also has some inherent strengths that you're not going to find quite yet in other kinds of disks that try to overcome master boot record's weaknesses. I'm going to talk quickly in this diagram about master boot record disks versus what are called GUID partition table disks. GUID partition table disks overcome some of the limitations found in master boot record disks. As you can see, the maximum partition size for a master boot record disk is 2 terabytes, whereas the maximum partition size for a GUID partition table or GPT disk is a whopping 256 terabytes. That's a lot more than 2. And if you need to have verification of that, go to Wolfram Alpha and type 256 minus 2. And you'll get a result of 254 more terabytes available on a GUID partition table disk. The other area where a GUID partition table disk just wipes the table with master boot record is in the maximum partitions that are available per physical drive. Remember, a master boot record disk has only 4 available partitions, although you can get more volumes on the disk by using extended partitions, but a GUID partition table disk allows up to 128 partitions per drive. Now, are you really going to need 128 partitions? Probably not, but there are cases where you may want more than 4 as well. You may want to have different data sets on different disks, things like that. With a GUID partition table disk, it's a little easier to get those additional partitions. There are some catches, however. Master boot records are supported everywhere. Basically, every version of Windows supports the master boot record disk type, and these partitions are bootable. Remember, the active partition on a disk is the bootable partition on a master boot record disk. As far as booting goes, only 64-bit systems with what's called an extensible firmware interface BIOS can boot from GPT-based partitions. So, first of all, if you have a 32-bit version of Windows 7, you're done. You're not going to boot from it. Second, if you have your typical regular everyday BIOS, not an EFI BIOS, you're done. You're not going to boot with it. So GUI ID partition tables are not generally suitable for booting systems because not everything has an EFI BIOS yet. Over time they will. Macs come with an EFI BIOS. Eventually you'll see it coming into more PCs. But for now, it's a little bit harder to find an EFI BIOS than it is your typical everyday BIOS. Now the other catch is the versions of Windows that are supported. Now master boot records are going to support or do support pretty much everything from Windows 3.1 on up to Windows 7. GUI ID partition table disks support recent versions of Windows, such as Windows Server 2003, Windows Vista, Windows Server 2008, and Windows 7. Now, don't forget that just because Windows supports it, if you don't have that EFI BIOS and a 64-bit version of Windows, you're done. You're not going to boot with that GPT disk. So for boot disks, it's probably best for you to just stick with the master boot record type. If you have a second hard drive and you want to be able to partition the living daylights out of it, go ahead and use GUI ID partition table, but only if you really need the benefits that come with the GUI ID partition table type disk, including larger partitions and maximum partitions per physical drive. Now, just as an aside, I will tell you that I actually, at where I work, have deployed GUI ID partition table disks for specific uses. We needed a larger partition than 2 terabytes for one of our applications. So I created a volume on the server that was of a GUI ID partition table disk type. And I created a volume that was much larger than 2 terabytes. So there are some real world cases where you really need to use GUI ID partition table disks. For the boot disk, not such a good idea. For data storage, though, it's actually not a bad idea to use them if you need to. If you look in Disk Manager, which we're going to be going over to a real system in just a few minutes to do that, but if you look in Disk Manager, this is what a basic disk would look like. First of all, you've got 2 basic disks here. There's 2 volumes on this Windows 7 system. They're both of the master boot record variety. And as you can see, there's a system reserved here of 100 megabytes, very small partition. But then there's the C drive partition that has almost 127 gigs of space. And you can see this is the boot partition. So this is the active partition on the system. The second disk has 4 partitions. We have 3 primary partitions, each named Primary 1, Primary 2, and Primary 3. And they're all healthy. And then we have this extended partition with the dark green. As you can see, it encompasses those 4 areas that you see here. Inside this extended partition, I've created 3 logical volumes. And as you can see here, they're extended 1, extended 2, and extended 3 of different sizes, just so I didn't want to just use 100 megabytes everywhere. So you can see that these ones are 100, 100, and 200 megabytes. And then there's still 126.31 gigabytes of available space that I can use in this extended partition. I'd only be able to create more volumes in the extended partition because I've already got 3 primary partitions. And as you can see here, Disk Manager gives you a really handy color coding chart that tells you which ones are primary partitions, which ones are extended partitions, where your free space is, and which ones are just logical volumes or logical drives. Here's a look at Disk Manager using a GUI ID partition table basic disk. Again, it still says basic disk. It's the same size. It's just disk number 3. But you see here that I've got 5 primary partitions, and they're all indicated by the dark blue. So GPT 1 through 5 are all 100 megabyte partitions that are on a GUI ID partition table type setup. So I've basically got 5 partitions on this single disk because I've chosen to use the GUI ID partition table type. So that's what you need to know about basic disks. You're going to learn a little bit more about how to manage basic disks in just a little bit. But before we get into the demonstration side of this, I want you to understand what are called dynamic disks. Now, when we talk about having to increase capacity or protection or the speed of a disk array on a Windows 7 system, you're going to start talking about dynamic disks, and you'll see why in just a few minutes. First of all, dynamic disks overcome a number of limitations, from particularly the master boot record type disks, and frankly the GUI ID partition table type disks. There is support for about 2,000 dynamic volumes per disk. Remember, a master boot record can have up to 4 primary partitions, but lots more in the extended partition space. But a GUI ID partition table disk can have 128 volumes. If you want to have 1,975 or even 1,976 volumes on a disk, you got to use a dynamic disk. As far as space goes, when you have a physical hard drive, if you use the basic disk variety, you're basically limited to whatever the capacity of that disk is. If you need more disk space, you have to add drives and do some other funky stuff to make it all work. With a dynamic disk, you can extend volumes to span multiple disks so they appear to be one large volume. Now, if you remember, back to the scenario, we have business analysts at Global Mantix that need tons of space. Well, by spanning disks, you can give them all the space they need without having to do all kinds of crazy stuff, like give them multiple volumes and things like that. You can keep the user experience very simple by saying, you've got your massive C drive or D drive here, just use it all. And as they need more space, just continue to add disks to their system. Now, there's some other things that you can get from dynamic disks as well, including increases in speed. You can improve performance by striping data across multiple disks. Now, in the storage world, you hear the phrase spindle count a lot. What that really means is the more hard disks you throw at a problem, the better performance you're going to get out of the storage solution. So, by throwing more disks at the problem and then striping data across those disks, you're basically getting 2 times the performance that you would get there's some complex calculations that go into it, but you're going to get roughly double the performance that you would get from your typical setup. And it may not be double, but you're going to get better performance than you would get from a single drive setup. You can also get better reliability by doing what's called mirroring data across multiple disks. So instead of striping that data across multiple disks, you can then mirror your data. So remember, the database administrators at Global Mantix need protected data. They want to make sure that if they have a problem with a hard drive, that it doesn't bring down their whole system. You can mirror their disks, that is, basically make a copy of one disk and plop it on another, and you'll be able to have 2 copies of this data always sitting around, always being maintained, so that if something does happen, then they can recover very quickly by going over to the mirrored copy of the data. These are some of the real benefits to dynamic disks, and they're huge. And we're going to be doing some demonstrations of this in just a few minutes so you can get a better understanding of exactly how all of this works. There are different types of dynamic disks. We have your simple volume. You kind of saw simple volumes before, even under the master boot record and GPT type disk. It's just a single volume that just sits there and holds data. You then have what are called spanned disks. These are a bad idea, but they have some benefits. Basically, when you span volumes, you take a single volume and you stretch it across multiple hard drives. Now, you get some significant performance benefit, but you also take a huge risk. If any one of the disks in that span fails, you lose the entire volume. So let's say you've got 4 drives and you span a huge volume across all 4 of those drives. But drive 3 fails. You lose all the data on all 4 drives because there's no protection mechanism for making sure that that data gets protected. And that same goes for striped. That's called RAID 0. It's a little bit different with a striped disk. It's another method that the data can be written to the disk, but you suffer the same consequence if you lose a drive. So if you need performance and you're not that concerned about the data going away, then it's not a big deal. Go ahead and stripe the disks or span the disks so you can get that additional performance benefit. Now, the business intelligence guys at Global Mantix, they may be okay with spanned or striped disks because they want the disk performance, and if they lose their disks, they can always get the source data again from the central storage repository at Global Mantix. Mirrored disks are called RAID 1. Now, RAID used to stand for Redundant Array of Inexpensive Disks, and now it stands for Redundant Array of Independent Disks. Basically what it is a number of separate hard drives that are put together in different configurations to achieve different goals. RAID 0 achieves the performance goal, and that's where data is actually striped across the disk. So when I say striped, what that means is, let's say you've got 4 disks in a RAID 0 array. It's going to write 1/4 of the data to each of those 4 disks. So rather than just writing everything to one disk, it's going to be able to improve your write time because instead of having one disk have to handle the entire write load, 4 disks at the same time will have to handle 1/4 of the write load. So that's where you start seeing your performance gain. Mirrored disks are called RAID 1. Now, mirrored disks basically do what I said before, which is make copies of the data on 2 drives. There is a bit of a performance hit when you have mirrored disks. You basically take a 2-to-1 performance hit on writes. Every time you write to the disk, it requires 2 operations, 1 for each disk, in order to function. So there is a little bit of a performance hit, but it's worth it as far as protection of the data goes. Now, RAID 5 volumes you're going to see shown in disk management, but they're not supported in Windows 7. RAID 5 is decreasingly common in data centers, but still very common, even though it's not quite as popular as it used to be. RAID 5 is a storage mechanism that uses what's called the concept of parity and that's P-A-R-I-T-Y, not the kind of funny stuff, parity, that is calculated on the fly that helps recover from the loss of any disk in the array. So let's say you've got a 10-disk RAID 5 array and disk 7 fails. A RAID 5 array can recover from that automatically by rebuilding disk 7 using all of this other information, this error-correcting information called parity that's scattered around all the other drives. That said, you're going to see RAID 5 grayed out in Disk Manager. The reason it's there is because Windows Server 2008 R2 and Windows 7 share similar code. Windows Server 2008 R2 does support RAID 5 volumes. Windows 7, however, does not. I wanted to point it out because it is grayed out, but it's not supported. I'm a very visual guy, so I want to try to create diagrams for you that will help you understand what I'm talking about. So I tried to throw this together, and I hope that it works for you. What this is a volume types diagram that basically shows you 1 unit of data and a fractional unit of data. So let's take a look at what this actually does. On a simple volume, when you write a unit of data, it goes to a disk. Pretty simple. On a span volume, when you write to a disk, basically this is 2 volumes put together, it writes it to one or the other of the disk. It doesn't write it to both, it doesn't stripe it, it just, once this disk fills up, it moves to this one. With a striped volume, when you write 1 unit of data, let's take 3 disks. 1/3 of each of that unit of data is written to the disk. So as you can see, there is a 1/3 on each of the disks. As I mentioned, if this disk happens to go away, this is all gone. So you got to be careful about using striped volumes. Now, people often confuse spanned and striped volumes. When you stripe, you're basically taking the 3 disks together and striping that data across all 3. When you span, you're waiting for the first disk to fill up, and then you move on to the second disk. With a mirrored volume, you have 1 unit of data that sits on the primary disk, and then 1 unit of data that sits on the secondary disk. So the data is mirrored. Now the reason I put this in red is because you lose this capacity. So with a mirrored system, you lose 1/2 of the capacity in your system. So let's say you've got 2 1-terabyte hard drives in your Windows 7 system, and you decide to implement a RAID 1 or mirrored setup. You're going to lose the capacity. You're going to exchange the capacity of the second disk for the protection that you're offered by mirroring the data. So the whole storage paradigm here revolves around a trade-off. You got to decide how much space you're willing to give up for protection. With a case of mirroring, you're giving up about 1/2 of the space, which is okay in a lot of cases. As I've mentioned before, I do a lot of storage at my day job. I actually do use a RAID 1 type setup for a lot of things. There are some significant performance gains with RAID 1, even more than RAID 5, that you start getting into when you look at larger storage systems. So a lot of people, if you look at just the capacity side of this, would say, well, why would you ever use RAID 1? You lose half your disk. There are some good reasons to do it. Finally, we've got RAID 5. And here you can see that we've written 1 unit of data, but 1/2 of the data goes one place, 1/2 goes to another, and then there's parity that goes to another. Now, with RAID 5, it doesn't actually write 1/2 of the data and then 1/2 of the data in parity here to a separate volume, but in essence, that's what's going on from a capacity perspective. With RAID 5, you lose, in a 3-disk configuration, you lose 1 disk's worth of capacity, or 1/3 of your capacity in a 3-disk system. If you had a 4-disk RAID 5, you'd lose 1/4 of your data capacity. In a 5-disk system, you would lose 1/5 of your capacity, and so forth. So just keep in mind that for RAID 5, you lose 1 over X, where X is the number of disks worth of capacity, in exchange for some protection for your data. Again, RAID 5 is very common in the storage infrastructure world, but you're not going to see it at the desktop side, particularly since Windows 7 does not support RAID 5 through software. You could get a hardware RAID adapter, but we're not going to be discussing hardware RAID in this course. But making sure you're not confused, I want to make sure that you understand that RAID 5 hardware is supported, but not RAID 5 as far as software Windows goes. If you were to put a RAID 5 adapter in your machine, Windows would use it in a RAID 5 configuration, but Windows itself cannot provide the RAID 5 services. You'd be reliant on the hardware to do that. Here is a disk manager view when we're looking at dynamic disks. First, you'll notice there are 2 disks, and they're labeled over here as being dynamic 127 gigabyte volumes, or in the case here, 126.88 gigabytes. Across the top over here, you see that there are a total of 6 volumes labeled Dynamic 1 through Dynamic 5 and MV1. Now I'm going to talk about MV1 in a second. What I do want to show you is we have GUI ID partition table type disks on dynamic volumes. GUI ID partition table works fine with dynamic disks, and you get some of the benefits of those GUI ID partition tables, and like the massive volumes and all that good stuff. So you can actually use GUI ID partition table in conjunction with dynamic disks, and you'll be fine. They're both listed as simple volumes. It's just the way the data is stored on the volume that's a little bit different. So GUI ID partition table disks work on both basic and dynamic disks. However, the simple volume and mirrored volumes and the other things we talked about, including RAID 1 and RAID 5 volumes, only work on dynamic disks. I want to point out this red one. This is a mirrored volume. It's 2 disks, and you can see here that there's a single volume that shares space on both disks. Both volumes are 126.38 gigabytes. So on both volumes, a capacity of almost 127 gigabytes has been reserved for a volume. In reality, this is taking up 2 times 126.38 gigabytes worth of space. It's taking up 126 gigs on each disk. Because each time data is written to this volume, it's automatically written to this volume as well. So every time you write data to a mirrored volume, it's written in 2 places. You can tell it's a mirrored volume because it says so right here, but also because it has the same volume name, same drive letter, and same amount of space. And now, the moment you've been waiting for, we're going to move over to a Global Mantic Windows 7 machine, and we're going to manage some storage volumes. On this machine, I've added 4 hard drives. I've got the master drive that's basically got Windows 7 on it that we're not going to play with. But then I've added 3 other hard drives that I have not yet initialized. I'm going to go through that process with you, and we're going to create a number of different types of volumes. And then I want you to understand how you can manage all these volumes. Before we get over there, I want you to understand that every volume has both a name and a drive letter. If you've been using computers for any length of time, you understand the C drive, the D drive, and the E drive. But every volume also has a name in Windows, and we're going to go over that as well. We'll then talk about formatting volumes and the difference between what's called the file allocation table and the Windows NT file system. And actually, on the next slide, I'm going to talk about the difference between file allocation table and NTFS. I'm going to actually go over that slide before we go over to Windows to do the work so you can understand the difference. I'll show you how to change a volume's drive letter, how to defragment your disks, and I'll tell you what that means, how to check a volume for errors, and view just the overall status of a volume. Before we go over there, I'm going to go to the next slide to show you the differences between FAT and NTFS, and then we'll move over to the Windows 7 Global Mantic system and do some work. There are actually 3 kinds of volumes that are available to you. There's file allocation table of what's called FAT32, which is the traditional FAT. And then there's this extended file allocation table, which is a little bit newer type of FAT than FAT32, but it's still a file allocation table type setup. And then there's the grand poobah of file systems for Windows called NTFS. Now, the Windows versions that are supported are very different with these 3 types of file systems. FAT32 is supported by every version of Windows that you're going to find in production these days. This extended FAT thing is only found in Windows Vista Service Pack 1 and Windows 7. If you've got the original Windows Vista or you have Windows XP, you're not going to see this as an option. This is one that you're rarely going to find in production these days. Very few people are using this extended file allocation table method, but you are going to see some FAT32, but a ton of NTFS out there, and we'll talk about all that in just a second. The maximum volume size under FAT32 used to be 32 gigabytes, but in most systems these days it's 2 terabytes. If you have a really old system, you'll be limited to 32 gigs. Just about every modern system these days will support 2 terabytes. With extended FAT, you can have a volume size of 64 zettabytes. I don't even know what a zettabyte is. It's like, 1 followed by a trillion zeros or something stupid probably, but it's a lot of data. NTFS has a maximum volume size of 2 terabytes. So there are some reasons to use some of these other types, but not generally very good reasons, because 64 zettabytes is insane. The maximum file size on a FAT32 disk is just under 4 gigabytes. It's like 4 gigabytes minus 4 bytes or something along those lines. So it's almost 4 gigabytes in size that you can have for a single file on a FAT32 partition. With extended FAT at 16 zettabytes, again, it would have to be one insane file to get to 16 zettabytes. And with NTFS, really your maximum file size is 2 terabytes. It's the size of the volume. So if you've got a 767 gigabyte volume, you can have a 767 gigabyte file sitting on that volume. The maximum file size is the size of your volume. From a security perspective, FAT32 is terrible. You don't want to use it in a lot of organizations. In fact, Global Mantic will not use FAT32 because you can't secure FAT32 very well. Now, I'm going to jump over to NTFS because it has a very granular permissions layer. You can assign to individual users very specific rights. Who's allowed to read to a file? Who's allowed to write to a particular directory? And we're going to be going over a lot of the file rights in another lesson in this course where we start talking about sharing files. So from a security perspective, Windows NTFS is where it's at, and that's what Global Mantic will be focusing on. EXFAT does have some rights and some security that are not found in FAT32, but it's still less than you're going to find in NTFS. For everything that Global Mantic needs, NTFS is going to provide what is necessary, and it's the predominant file system that you're going to find in organizations these days. Now I'm going to switch over to a Windows 7 Global Mantic machine, and we're going to go through managing storage volumes. And here we are at a Global Mantic machine. And the first thing I'm going to do is I'm going to open up the disk management tool so that we can create some new volumes. I told you before that we have 4 hard drives in this computer. Well, I've only got 1 volume here. Right now you see the C drive, and it's got 116 gigs out of 126 gigs free. Where are the rest of my disks? Well, let's go to the disk management tool in Windows and find them. The way I get to disk management is I go to the Start menu, right-click Computer, and choose Manage. This opens up the Computer Management tool, and you can see here that there's a storage tree, and we have a disk management tool. Now, if you've added new hard drives to the system, the first thing that's going to pop up is this initialize disk thing. You have to initialize your disk before the disk management tool can see it. And what kind of partition style do you want to use for the selected disks? Do you want to use master boot record or do you want to use GPT? Well, I'm going to stick with master boot record, so I'm going to click OK. Now what's going to happen is it's immediately initialized these disks, and you can see that they are all basic disks. So we're going to create a new volume on one of these disks. And the first one, we're going to leave them basic for now. But the first disk we're going to do is we're going to create 2 partitions. We're going to create 2 primary partitions, and then we're going to format them. So I'm going to right-click here, which is over in the the left-hand side of the disk icon, and I'm going to do, I'm going to click over here and do New Simple Volume. I'm going to create a 65 gigabyte volume. Click Next. And you can see that I'm going to assign the letter drive E to it. Again, I can go all the way up to Z. I can go from B. I got to skip C because it's already in use. D is already in use by the CD-ROM drive. And I can go E through Z. I'm not going to talk about these things here. You don't actually have to assign a drive letter, but it gets confusing if you don't. So you should generally assign a drive letter to your new volumes. We'll click Next. And you can see that I've got an option to format this with either NTFS or EXFAT. FAT32 isn't available here, but EXFAT is. I'm going to stick with NTFS. Allocation unit size for a desktop machine is generally not that important. When you start getting into very high-end storage, the allocation unit size is important. What you should understand here is that if you choose default, Windows is going to choose an allocation unit size that makes sense based on the size of the disk or the volume that you're creating. The allocation unit size is the minimum size of a file on the disk. So if you've created an allocation unit size that's 64,000 bytes or 64K, every file on the disk will take up 64K or 64,000 bytes of space, regardless of how small the file is. So if you've got a 2-byte file, it's going to take up 64,000 bytes on the disk. If you've got a 600 megabyte file, it'll take up 600 megabytes to the next highest 64K barrier. So it's just how it's going to space the data on the disk. I always use default for desktop machines. And the volume label will be Globo Mantix 1. You can perform a quick format, which basically just runs through the disk and gets it ready to use. Or you can deselect this and it'll do a more thorough format to look for bad sectors and other things that could be bad on the disk. I generally, because I'm using virtual machines, do a quick format because I know the disks are good. For a real machine, I would actually recommend that you do a regular format. If you want to, you can enable file and folder compression to get additional space out of your disks. However, for most machines, you're not going to need to do that. Hard drives are pretty big these days. If you want that space, go ahead and choose folder compression and file compression. There is a bit of a performance hit, but it's not that big. So we're going to use the NTFS file system with a default allocation unit size with a volume label of Global Mantix 1. And before you actually kick off the process, it's going to make sure that you chose the right options, and then you click Finish. And it's done. And you can see up here we've now got drive E. When I select it up here, it gets kind of these hash marks below so you know which one's being worked with. It's a simple basic disk of an NTFS file type, and it's healthy, and it's a primary partition. Now here we can create yet another simple volume. And I'm just going to run through and I'm going to do vol2. And we'll do the same process. And as you can see, I've just created 2 volumes on one disk. They are both primary partitions on a basic master boot record disk. The next thing I want to do is I want to convert one of these disks to dynamic and then create some more advanced volume types. So I'm going to right click over here in the left hand side of the space and I'm going to do convert to dynamic disk. So we'll convert it to a dynamic disk. And I'm going to convert both disks 2 and disk 3 to dynamic. And as you can see, they're both dynamic now. Now, when I right-clicked, I also want you to see that you can convert this to a GPT disk here as well. Remember, you can master boot record or GPT is the type of disk, but you can have basic or dynamic volumes on either one, either MBR or GPT type disks. Now, when I right-click over here, I can again choose different volume types. This time, I'm going to create a new spanned volume. Now, this is going to help me. As you can see, it says a spanned volume is made up of disk space on more than one disk. So if you need volume that's too large for a single disk, you can extend a single disk space by adding space from another disk. So I'll click Next. And as you can see, it's asking me which disks I want to include in the span. Which disks do you want to add? So right now I've selected one disk, disk 2, and I can add disk 3 to get a total volume size of 260 megabytes. So what's the maximum amount of space available and the amount of space in, okay, good. This is just telling you how much space there is on each disk. So you don't actually have to add the entire capacity of the second disk. If you wanted to, you could add just 20,000 megabytes or 20 gigabytes to the second disk. So this way you can say, well, I want to use part of a second disk augment the capacity of the first disk. And you'll see what that looks like in just a second. We'll give it drive G. We'll call this spanned. We're going to be deleting it in a second here, so I'm not too worried about what we call it. But it's going to be called span disk. And again, you have the summary page here that tells you that we're going to create a 150 gigabyte volume called drive G with an NTFS file system with a default allocation unit size. The volume name of span with a quick format with file and folder compression not enabled. And click finish. Now, as you can see, we've only used part of the space on this first disk. So drive G happens to be on 2 disks, and you can see that it says span volume down here, but we haven't used the entire capacity of disk 2. I'm going to delete this volume. And again, if you delete a volume in Windows, all the data on it is gone. So be careful about this, because I just created it. I know that it's safe to delete, so I'm going to go ahead and delete this volume so we can do some other demonstrations. Now, when you deleted that volume, it went back to a dynamic disk. So to a basic disk. So I want to reconvert this to a dynamic disk. And then we're going to go ahead and create a striped volume. Again, we have to choose which disks we'd like to include in the striping. And this time I'm going to go ahead and just use all of the capacity. It'll be drive G, and we'll call it striped. And it's got a different color. That's because it's a striped volume this time. And as you can see, it tells you the striped volume, and we're using the total capacity of both disks. So it's really just how much space you want to allocate to whatever you need, and you can choose those different volume types based on what the needs are in the organization. For the business intelligence guys at Global Mantix, a striped volume probably makes sense from a performance perspective. For the database guys, however, this would not be an appropriate configuration. Even though it gives you some additional performance, it really puts you at risk from a data recovery perspective. So I'm going to create a mirrored volume for the database guys on this machine. So I'm going to right click here and delete this striped volume. Reconvert these to dynamic disks. And then we're going to do a new mirrored volume. Again, it'll be drive G. We'll call it mirrored. You probably see what the naming convention is that I'm using. And this time when we create the volume, it's mirrored. This is a good thing. So we got a mirrored volume. We've got the little red color, and it's basically the same drive letter. Now, there may come a time when you want to change the drive letter. Maybe you're adding a new batch of machines, and for whatever reason, the drive letters aren't matching up, but you want all of your users using the same drive letters. Let's say you want all of your mirrored drives at Global Mantix to use drive M. Well, it's really easy. You right-click the volume, and you choose Change Drive Letters and Paths. Now you'll notice that it's going to bring up a Change Drive Letters and Paths window. You can click Change, and you can assign a drive letter of any type. Drive M. Now, this is extremely important. Don't ignore this message. A lot of people like to click through warnings. It's going to tell you some programs that rely on drive letters may not run correctly. For example, if you've installed programs that say, I want to go to drive G and I'm going to do the following, as soon as you change that to drive M, it's going to break them. So make sure that your applications that are underlying on the disk don't get confused by the change in drive letters. So when you choose yes, we end up with a drive M instead. And you can see up here that it's a dynamic disk mirrored. Now there may come a time when you decide I don't need the mirror anymore. You can actually break the mirror and use the space in other ways. If you right-click a mirrored volume, you can remove the mirror or you can break the mirror. If you break a mirrored volume, your data is no longer fault tolerant. Right now, if either one of these disks dies, you're not going to lose any data. If, however, you break the mirror, you will, if you lose one of those disks. But you can break the mirror. And it converts it to 2 simple volumes, each with having the same data. So let's say that you get to a point where you want to break a mirror because you want to maintain a copy of one of the pieces of data or one of the sets of data as it was in a point in time. You can break the mirror and then go ahead and keep the data that was existing and then start working with new data on the other volume. You would have to change the name of the volume as well. So from there, you want to change it from properties, and it's no longer a mirrored disk. So let's call this simple one. And on the properties page of the other volume, which again, this is now 2 simple volumes. Now you may be wondering why the names really matter. Well, when you go to My Computer, you're going to see that you have all of these friendly names on all of the volumes that happen to be in your system. So right now we've got the local disk, which is your C drive. We've got that GlobalMantic 1 simple basic disk that we created. Vol2 we created as the other half of this disk. Then we've got a G and an M drive, which used to be one single mirrored drive, which are now 2 separate volumes. So you've gotten to see how to create volumes. You've gotten to see how to change drive letters, how to change drive volume names. But one of the things we haven't done is check a disk for problems. You can do that in a couple of different ways. One, right from My Computer, this is where you're going to normally be working. You can right-click any volume, go to Properties, and on the Tools tab of the Properties page are a number of tools, as you would guess by the name Tools tab. You can go ahead and click Check Now to check the volume for errors. Back in the DOS days, this used to be called Check Disk. This is basically now a built-in error checking tool in Windows that looks for errors on a disk. You can tell it that you want to correct those errors, which generally you want to if there's a problem. You can also do a deep scan, which is going to actually scan the physical disk for recovery of bad sectors. A sector on a disk is the smallest unit that is stored on a disk, and it's a physical space on a disk. Hard drives do go bad after a while. So you can tell Windows that if you start seeing a sector that's bad, try to attempt recovery of the data from that bad sector and move it somewhere else. And this way you're proactively taking steps to make sure you don't lose data from your system by moving information from bad sectors to good sectors. I'm not going to do a bad sector scan on this virtual machine, but we will attempt to fix file system errors. When it's done scanning, you're going to see that it was successfully scanned, that there were no problems. And if you want to, you can get a look at all of the details that the scan process found. We're not going to go through what all of this stuff means, but if you have used this ever in DOS in the olden days, you'll see that a lot of this is very familiar information. That's a very simple error checking method. The next thing you need to do on a periodic basis is what's called a drive defragmentation, often called a defrag. When you save a file to a disk, it doesn't always write that file into a single contiguous space. Often, if it's particularly for larger files, that file is actually written to a whole bunch of different spaces on the disk, so it's not actually stored in one spot. That creates inefficiencies and performance loss on a system. So rather than the system having to go to one spot on a disk and grab a file, it's got to go here, there, and everywhere to get all the pieces of the file to bring it all back together. You can defragment your hard drive, which is a process of taking all of these files and putting them back together on the disk, which overall improves performance of your system. If you click Defragment Now from the each volume's property page, you can see that there's a scheduled defragmentation on by default that runs 1 a.m. every Wednesday. And this is the last time that defragmentation was run. You can change this schedule by clicking the Configure Schedule button, and you can decide how often or when you want to run a defrag. Do you want to run it daily, weekly, or monthly? If you choose weekly, which day of the week? And at what time would you like to run the defrag? You can then select which disks you would like to include in the defragmentation process. Honestly, you should include all disks. And click cancel because I'm not making any changes. And when you're ready, you can choose a disk and run analyze disk. And you can see right now that this disk is 0% fragmented. So there's no fragmentation right now in any of the disks. Frankly, it's when your disks start getting fuller that you start seeing fragmentation issues. So right now, because these disks aren't very full, you're not going to see them fragmented. And really, the defragmentation process is not dangerous. It runs at 1 a.m. because while a disk is defragmenting, there can be a performance hit. So you don't really want to generally do it in the middle of a day. We'll be talking about backup when we later in this course in a backup and recovery lesson, so we're not going to cover that right now. And you'll be seeing a lot of these other things handled, including security and sharing, later in this course as well. We covered a lot in this lesson, including the deconstruction of basic disks into their primary components. You'll learn about the difference between master boot record and GUI ID partition table disks, and you got some graphic views of what Disk Manager looks like with each one of these different kinds of disks. We then talked about dynamic disks and some dynamic disk volume types to help enable some of what GlobalMantix needs for some of its workers, specifically the business analysts and the database guys. You learned about the different types of volumes, including RAID 0 or striped, span disks, RAID 5 or parity disks, which you can't use in Windows 7, and mirrored disks, which are RAID 1. You then got to look at Disk Manager with dynamic disks in place, and then we went over to talk about FAT and NTFS, which you'll be getting a lot more exposure to later in this course. Finally, we ended by covering some walkthroughs of storage management in Windows 7. If you'd like some more information about the difference between basic and dynamic disks and GUI ID partition tables and how that interacts with Windows, here are some supporting resources. Thank you for listening, and I look forward to the next lesson.